Hey everyone, so we're busy working through exercise 2 of our metric trigonometry notes. I decided to skip number 2 and 3, and you can just pick up the answers from my photograph, my memo. We are now on number 4, which asks us to evaluate without using a calculator, and firstly they give us cos 75. Okay, the way that I'm suggesting you do it is because no calculator is suggested, we're going to have to use special triangles. So we can break 75 into a cos 45 plus a cos 30. Okay, using our compound angles, we can expand that to cos 45 cos 30 minus sine 45 sine 30. Now special triangles, root 2 over 2 is cos 45, cos 30 is root 3 over 2 minus sine 45 is root 2 over 2, and sine 30 is a half. Okay, so now as best you can, you're going to just simplify that. I'm not going to spend too much time on that. It's just simplification of fractions, and I think your end answer works out to be root 6 minus root 2 all over 4. Okay, so that's how you would go about that question. Number 4.2, sine 15 plus cos 15 all squared. The square applies to everything, so you're basically going to FOIL that bracket out. You're going to have sine squared 15 plus 2 of sine 15 cos 15 plus cos squared 15, right? The sine squared 15 and the cos squared 15 are together going to give you 1 plus 2 sine 15 cos 15. Right, that there is actually an expanded double angle. So if I wanted to reduce that back into a double angle, it's going to be sine 2 times what angle have we got? 15, which is 1 plus sine of 30. You should know that sine 30 is a half, so that means 1 plus a half, which our answer for 4.2 is 3 over 2. 4.3, I've said here, is a tricky one because you have to kind of start backwards and work towards this answer. So first of all, we're going to start with cos 45. You will have noticed that this square and this 22,5 kind of point you towards the fact that we're going to deal with cos 45. You know that cos 45 would also be what cos 2 times 22,5 is. Do you agree? Same thing. Cos 45 we know to be root 2 over 2. Cos of 2 times 22.5, we could use our double angles to rewrite that as 2 cos squared 22,5 minus 1. Do you see we are asked to find out the value of cos squared 22,5. Now, through what we've done, we have got a cos squared 22,5. So what's left is for us just to move stuff around and get that to be the subject of the formula. So root 2 over 2 plus 1 would be equal to 2 cos squared 22,5. And if I had to bring that to the front now, cos squared 22,5 would be equal to what? If you had to take that and divide by 2, okay, you're going to get, I think, your calculator could help you, even though it says don't use it, but I think the end answer is root 2 plus 2 over 4. Okay, you've just divided the left-hand side by 2, and there you have found what cos squared 22,5 is equal to. Number 5, I think I may have mentioned this in the last video. If tan 25 is equal to m, use an appropriate sketch and express each of the following in terms of m. There is my sketch. 25 is in the corner there. Tan is opposite over adjacent, so m is my value for opposite, and adjacent is 1. That means my hypotenuse would be what? The square root of m squared plus 1 squared technically. So I need to fill that in because I might use it just now. So in 5.1, I have to work out the value or in terms of m of sine 50. So because I want to use double angles, I'm going to change my 50 into sine of 2 times 25, which we know is 25 is our angle that's given in our story. So now using our double angle, that's going to be 2 sine 25 times cos 25. So now grabbing what sine is what over what? Opposite over hypotenuse. Opposite is m, hypotenuse is root of m squared plus 1. Cos 25 would be what? 1 over root of m squared plus 1. Great. So now, moving this forward one more step, the 2 over 1, I guess, 2 times m times 1 would leave us with 2 at the top. And what is at the bottom? The roots are going to cancel each other, and we're going to have m squared plus 1 at the bottom. Tricky one as well is tan 50. You do not have a double angle for tan, so you can't do the same thing as we did in 5.1. So we're going to have to say sine 50 over cos 50, which is obviously what tan 50 would be equal to. Okay, then we have already got an expression for sine 50. We know what it is. It's over there. So I'm going to leave it as sine 50 for now, and later on I'm going to bring 5.1 answers in. Cos of 50 I'm going to rewrite as cos of 2 times 25. Cool. So I've got my double angle now, and now I can say sine 50, and I'm going to replace my cos 2 times 25 with 2 cos squared 25 minus 1. 25 is our key number here, so we're running with it. Now I'm still, well, let's bring in our answer from 5.1. So my numerator is 2 over, I think it was 2m, sorry, 2m over m squared plus 1, all over, okay, 2 of what is cos, and what is cos 25, and we're going to square it, eh? So cos 25 was 1 over square root of m squared plus 1. There it is, minus 1. So we've got quite a big fraction to deal with now, which we're just going to have to mess around with a little bit. So if we could first of all say, let's just leave the top 2m over m squared plus 1, nothing too much to do there. When I square this bracket out here, 1 squared is 1, times by the 2 is 2. When I square the root, I'm going to have m squared plus 1, and minus 1 is still chilling over there. Okay, just to move rightwards, I'm going to take my answer and go over there. I want to first of all bring in that minus 1. So 2m over m squared plus 1 is fine. I'm going to just leave it like that. And now I'm going to bring in that minus 1. So I need a HCF, or a LCD, sorry, at the bottom, m squared plus 1. I've already got a 2. I'm going to minus what? M squared plus 1. But it's got to be in brackets. I'm going to minus the whole thing. So instead of doing the brackets, I'm just going to say 2 minus m squared minus 1. Does that make sense? Right, so moving on one more step. This is just algebra here more than anything, eh? 2m over m squared plus 1 over, what do we have left now? We have got what? 2 minus 1 is 1 minus m squared over m squared plus 1. Great, this is looking a bit messy, but bear with me. Now let's get out of this double fraction thing. 2m over m squared plus 1, instead of dividing by the bottom, I'm going to times by the flip. There we go. Now we can cancel the m squared plus 1s, and I'm going to be left with our final answer of 2m over 1 minus m squared. Hashtag mission, because it was quite a mission. Okay, but just look carefully, make sure you understand where I went. 5.3, cos of negative 65 is going into the fourth quadrant, which we know is cos's quadrant, so that is simply cos of 65. Cos of 65, using our co-ratios, is the same as cos of 90 minus 25. Now I can bounce into sine 25 through our co-ratios, and from our picture, we know that sine 25 would have been what? Opposite is m over hypotenuse is m squared plus 1, right? Or root m squared plus 1. 5.4 is sine of 85. 85 has got nothing to do with our picture. So we are going to have to break 85 into sine of 25, or let's go with our special angle first, 60 plus 25. Using our compound angles, we're going to say sine 60 cos 25 plus cos 60 sine 25. Right, so we've got a mixture of special angles and the angle we've got here. Sine 60 is root 3 over 2. Cos 25 from our story is 1 over the square root of m squared plus 1. cos 60 is a half, and sine 25 from our picture is m over root m squared plus 1. Once again, it's just a case of multiplying things out and all that, but because our LCDs are the same, that's an ugly 2 there, by the way. Because our LCDs are both the same, that means you could just simply add the numerators together. The numerators are root 3 plus m if you add the numerators together. And the denominator is 2 root m squared plus 1. Why could we do that? Because we had our lowest common denominator already. 5.5 to finish question 5. Cos 205 can be written as cos of 180 plus 25. That reduces to negative cos 25, which is negative of what? 1 over root m squared plus 1. Great. So question 5 done. Moving on to question 6. As follows. It says, if tan b is root p, use the appropriate diagram to determine what cos 2b is in terms of p. So I've drawn a little 90-degree triangle again. If I've got tan b is root p, that would make root p over 1. So this hypotenuse would be the square root of what? Root p all squared plus 1 squared. What is root p all squared? It would be p plus 1. Great. So now I've got all three opposite, adjacent, and hypotenuse, and I can now see what my question really wants. It wants what cos 2b is. So we want to get rid of that double angle and make it just a normal b. So the easiest way would be to change that into cos squared b minus 1, which would be 2 of something squared minus 1. What is cos in my picture? It's adjacent over hypotenuse, so 1 over root of p plus 1 all squared. So when I square out that bracket, 1 squared is 1 times the 2 will be a 2. And when I square root the p plus 1 under root, I'm just left with p plus 1 minus 1. I have to join those two things together into one fraction. So my LCD would be p plus 1. I've already got a 2, and I'm going to minus p minus 1 at my numerator. So 2 minus 1 gives me 1 minus p over p plus 1, and there is my answer for number 6. Number 7, I've already labeled it as quite a tricky one, and we have to start with the circle identity. It's a bit of an awkward starting question, but watch carefully. We are asked in 7.1 to work out the value of sine 2a if we know cos 2a to be equal to n. And the way we're going to do it is we are going to say cos squared 2a plus sine squared 2a is equal to 1. Furthermore, if cos 2a is n, this would be n squared plus sine squared 2a equals 1. We are after sine 2a. So now it's a case of getting sine 2a as the subject of the formula. So sine squared 2a would be equal to 1 minus n squared. Therefore, sine 2a, what we're after, would be the root of 1 minus n squared. Awkward question. Doesn't appear too often, but be on your toes. 7.2 then say, what is sine A? Also an awkward start would be to start with cos 2a equals. What can cos 2a change into? 1 minus 2 sine squared a, right? That there is where our answer lies. Cos 2a we can replace with n minus 2 sine squared a, and now it's also just a case of getting the sine a on its own. So if I had to bring the sine or the 2 sine a or sine squared a to the left, I'm going to have 1 minus n on the right. 1 minus n will then be written over 2, 1 minus n over 2, and lastly, to find sine a, we would have to square root 1 minus n over 2. Tricky, tricky. Right, I'm going to try push through. This is going to be a long video. Number 8 asks you to simplify into a single trigonometric ratio. Right, there it is, my question. Cos of negative 60 is negative cos 60. Cos of 126 can be written as Sorry, it's not 1. It is 126, my bad. Cos of 126 can be written as sine of 180 minus 54. And sine 747 is the same as sine 27. Why? Because I'm going to go 360, I'm going to go 720, and I've just got 27 to go. There we go. All over. Cos squared 207 is the same as saying cos squared of 180 plus 27. And sine 63, I guess we could also, you see 27 is quite a popular number here. So I could change sine 63 into sine 90 minus 27. Now, negative cos 60, we know that, well, it's actually not negative, my bad. That's not negative. That over there is going into cos's quadrant, so it's not going to be negative. Cos 60 is a half, so that I can substitute out. Sine of 180 minus 54 is sine 54, because we're going into sine's quadrant. Plus 27, sine 27. Think carefully now. Cos squared of 180 plus 27, if the square was not there, that would become negative cos 27. But because we're squaring, we're going to square out the negative, and we're going to get cos squared 27. On the right part of the denominator, sine of 90 minus 27 is a co-ratio. That's going to give us cos of 27. Getting there. Might have to move number 9 down here. Half is still just going to chill there. Sine of 54 is the same as saying sine of 2 times 27 plus sine 27. So now we entirely have got 27s everywhere. At the denominator, by the way, we could actually so long take out a cos 27 as an HCF. What would be left? Cos 27 plus 1. You'll see just now, and I'm just going to rub out this number 9. Is this even an eraser? I don't know the stuff. Okay, number 9's gone. If I expand this sine to 27, I'm going to get 2 sine 27 cos 27 plus sine 27. All over. Cos 27 brackets cos 27 plus 1. The half and the 2 are going to cancel each other out. Now I can take out an HCF at the top of sine 27. What's left? Cos 27 plus 1. And when you look at that, I'll be able to cancel out my brackets entirely. I'm left with what? Sine squared 27 over cos squared, there's no squared. Sine 27 over cos 27 is tan 27. Would you believe that? Hectic, hectic. Number 9. Number 9 says, in fact, yeah, let me hang in there and do number 9. Number 9 says, in triangle ABC, B is equal to C, so we've actually got an isosceles triangle here, and it's equal to theta. Prove that cos theta is equal to A over 2B. Okay, so we're actually going to use the sine rule from grade 11, and we are going to say the following. Before we really get into it, because so much is going to be revolving around angle A, you'll see. Angle A would equal 180 minus 2 thetas. Would you agree? And we could also see that B would be equal to C, right? Because it's an isosceles triangle. Let's just write here, B is equal to C. Angles opposite equal sides. So now using our sine rule, remember we have to work with theta. So sine, let's go slowly here. So sine of A, of corner A, over A would be equal to sine of, let's say, whatever, let's say sine B over B. Cool, that's our basic formula. Now we're going to sub stuff in. Okay, and I don't know why my eraser is not working. I'll clean out number 10. But now let's bring stuff in. So sine A would be sine of 180 minus 2 theta over A, right? And sine B is then sine theta over B. Cool, I'm going to have to squash things up here because my number 10. Sine 180 minus is taking us into the second quadrant, which is sine 2 theta over B, over A. is equal to sine theta over b. Sine 2 theta can be replaced with 2 sine theta cos theta, right? And while I'm at it, let's just go over a, is equal to sine theta over b. So ideally now we want cos theta on its own. That means that the a at the bottom is going to join the sine theta at the top, and the 2 sine theta is going to join the b, 2 sine theta at the bottom. What do you notice is going to happen now? The sine thetas are going to cancel, making cos theta equal to a over 2b, which is what we were given in the first place. Apologies for it being quite untidy, but that is number 9 for you over there. Okay, the video is going to go on for a long time. Apologies, but I do want to quickly get through number 10 because this could be the last video I'll be able to make. Number 10, it says on the top of your next page, solve for x if x is between negative 180 and 360. So this is now a specific solution, not just a general, of the following: sine 2x plus sine x minus 2 cos x minus 1. Right, because general solutions you need to first factorize, we're going to have to deal with that and probably also factorize. So firstly, sine 2x is 2 sine x cos x plus sine x, I can't do anything there, minus 2 cos x minus 1. This is going to be a case of, let's just say equals 0, of grouping, right? You've got 1, 2, 3, 4 terms over there. So between the first 2 terms, I could take out a sine x as an HCF. 2 cos x plus 1 would be left. From the next 2 terms, I'm going to technically take out a minus 1. Then I would have 2 cos x plus 1 left. That means I've got a common bracket of 2 cos x plus 1, and my other bracket will be sine x minus 1 equals 0. Remember, both brackets are going to have a chance to be general solutioned. So firstly, this guy, cos x would equal negative a half, or sine x would be equal to 1. Great. Now, when we deal with the left-hand side, remember, when is cos negative? Cos is negative in the second and the third. So we are going to go shift cos a half. Remember, don't type in the minus. And you're going to get 60. So x is equal to, let's do the second quadrant, 180 minus 60 plus 360k. Or, let's do the third quadrant, x is equal to 180 plus 60 plus 360k. So to clean up my cos side of things, x would be equal to, not 200, would be 120 plus 360k, or x here would be equal to 240 plus 360k. That takes care of this, the cos side of things. Now we can look at the sine side of things. Sine is positive when? Quadrant 1 and quadrant 2. If I had to say shift sine 1, I'm going to get 90 as my answer. So I would have said 90 plus 360k, or 180 minus 90 plus 360k. Either way, I'm going to get x equals 90 plus 360k. Somewhere in your answer, you've got 1, 2, 3 general solutions. Please write k is an element of z, integers. Then we have to now go and work out the specific solutions. Remember, the interval is negative 180 up to 360. So the answers immediately that fit in are 120 fits in, 240 fits in, 90 fits in. But we have to add in a few more if we can. Firstly, looking at our first general solution. If I add 360, I'm going to be too far. If I take 120 and minus 360, I'm going to be too small. So I can't do anything else on the first side. If my second general solution is 240 and I add 360, I'm going to be too far. But if I minus 360, I'm going to be negative 120, which does fit into my interval. My third general solution here, if I add 360, I'm going to be too far. And if I minus 360, I'm going to be too far. So I've actually got my 4 specific solutions, which usually we rewrite in ascending order, which would be as follows. Great. So that's the end of exercise 2. We now move on to equations, which I've just done one of them. I don't think I'm going to be able to do any videos because I've been borrowing this fancy iPad, but I will be in touch with you on WhatsApp, and all the best for the last few pages of triangle formula and the rest of trig.